Hello and welcome to the first lecture of this new section on real-time monitoring and alerts in this course, AI for Risk Management and Compliance Excellence. So in this section, we will give you a good idea of how can you build excellence in real-time monitoring and alerts. And particularly in this lecture, we'll talk about one of those things to use, which is real-time data ingestion and analytics pipeline. So how do you think you can use real-time data ingestion and analytics pipeline to enable continuous monitoring rather than periodic checks, ensuring real-time visibility into risks? Longish question, right? Right. You know, using real-time data ingestion and analytics pipeline is essential for to enable continuous risk monitoring instead of relying on delayed periodic audits. Now, this approach allows your business to detect and respond to threats as and when they happen, whether they are like financial anomalies, whether they are cyber intrusions, compliance breaches, or reputational risk. Now, what are the various steps that you need to take to implement real-time pipelines for risk visibility and mitigation? Let us take a look at these steps. So before we do that, let's take a look at how does this real-time data ingestion analytics pipelines enables, what all does it enable? So in traditional checks, what you do is on a weekly or monthly basis, you do batch audits of your data, right? And here in real-time monitoring, it's a continuous data ingestion and live risk scoring. Live is the key word, right? And in traditional checks, you have manual reports, whereas in real-time monitor, you have automated dashboards and alerts. And in traditional method, there is a lag, high level of lag between event and the action. Event is something that is happening that produces risk. And in this case of a real-time monitoring, your risk is detected instantly and you can begin to mitigate it, right? You can take action to mitigate it instantly. So that's what it enables, right? So let's take a look at the first step. Obviously, the first step is to identify the real-time risk data sources. And you do that by mapping which events, logs, or data streams carry risk signals, because there should be something that carries the risk, right? Doing something. So you start mapping. And what are the various domains and real-time sources? In finance, these are like transactions, payments, account behavior. In cybersecurity, you have firewall events, server logs, login attempts. In operations, you have IoT sensors, logistics feeds, inventory updates. In compliance, you have policy violations, email communication, access logs, and in reputational risk, it is social media mentions and news articles. So you start mapping which events and logs and data streams carry risk signal out of these based on your domain. Then you ingest real-time data using streaming sources, and that you do by setting up the streaming ingestion architecture to pull in live data. Again, the key word is to pull in and live data. And the whole thing is to set up this architecture. Now, what are tools and technologies that you can use to set up this streaming ingestion architecture? So, at a data ingestion layer, you could use tools like Apache Kafka, AWS Kinesis, Azure Event Hubs. For processing those stream of data, you can use Apache Flink, Spark Structured Streaming, Kafka Streams. For ETL and ELT, you could use dbt, Airbyte, or Fivetran in real-time mode. And for storage, hot storage, you can use Apache Druid, ClickHouse, and Elasticsearch. So these are various tools and technologies that you can use. Let's take a look at an example of these technologies. So a bank suggests payment transactions. And for that they use Kafka. They process them with Flink and stores flag anomalies in Elasticsearch for immediate review. So three technologies there in this whole example of the a part of the architecture of real-time data streaming and usage. The third step would be to apply the real-time analytics and machine learning models. And there you analyze the incoming data instantly using risk detection logic or machine learning. Either of those. Either you have a risk detection logic or you use machine learning. Now, what are some examples of both of these? Now, you could use in a rule-based flag, you could be flagging saying transaction greater than $10,000 from offshore accounts become your flagging event. And in machine learning models, it could be fraud detections, insider threat scoring, and anomaly detection. So these are some examples of each of these, right? Now, what are the machine learning techniques for streaming? Now, you can use pre-trained models loaded with stream processors. That's one possible approach. Or you could use online learning models updated on the fly. Or you could use a technique called sliding window aggregation as, let's say, example, user behavior in last 10 minutes. So these are three core techniques to apply real-time analytics and machine learning models. Then you trigger real-time alerts and automated action. Now, when a risky pattern is detected, you can, you can trigger alerts and the workflows, and you have notification channels that you see here. Could be email, Slack, SMS, Wire, Twilio, PagerDuty, or you could have an incidence response tool, you like ServiceNow and Jira, where the response is built in and the response happens. Or you could do auto mitigation, things like blocking the user, pausing the transaction, etc. etc. Now, a good example of this would be a user logs in from two countries within 2 minutes, and the system blocks the session and notifies IT security instantly. So that would be an example of triggering real-time alerts and automated actions. Then you can visualize risk signals on live dashboards. You can use live dashboards for ongoing risk visibilities. And you have tools like Grafana, Kibana, Power BI real time, and Streamlit. And there you can use these dashboards to show risk heat maps by regions or systems, anomalous activity feeds, and real time policy violation counter. So that's how you can visualize risk signals on live dashboards. Then you need to have feedback. You can have feedback loops and model retraining. So there you need to continuously improve the accuracy of the detection models. And there are a couple of things you can do. One is to store the flagged incidents and feedback. And these are typically the false positive things that you think are happening, which are not happening. False positives. And once you have you store these flag incidents, you can retrain model weekly, monthly using this data and enable human in loop validation and keep doing this entire process for model retail training. Then you need to also look at your secure and audit pipeline, and basically you need to ensure compliance and integrity by encrypting all in transit and at rest data, right? And logging all actions and decisions and integrating with GRC system for auditability. So that's how you can secure and audit your streaming data pipeline. Let's take a look at real world example of continuous AML monitoring in a banking system. So the data source is live customer transaction via Kafka, and they're live, real. And your streaming happens through Flink, which detects patterns like structuring or high velocity trade. And then the trained machine learning model scores risk for each transaction. So this is scale again. And then ServiceNow creates cases for compliance officers. And the outcome is fraud detected in seconds, not days. So that's a real world example of a continuous AML monitoring, anti-money laundering monitoring in a banking system. Let's take a look at the tech stacks summary. So in the ingestion stage, you could use Apache Kafka, AWS Kinesis, Confluent Cloud. In processing of that data, you could use Apache Flink, Spark Streaming, Fast, that is in Python. Then in model scoring, you could use TensorFlow, PyTorch, scikit-learn via ONNX and Torch script. For storage, you could use Elasticsearch, Druid, BigQuery, Snowflakes in terms of streams. For dashboarding, the familiar Kibana, Grafana, Power BI, and Streamlit. And for orchestration, you could use Airflow and Prefect. So these are the various layers and tools and platforms in the tech stack for real-time data ingestion and analytics pipeline. So what is the business impact of using real-time ingestion and analytics pipeline for continuous monitoring? You get real risk visibility in seconds, and you can respond to threats instantly. So instant responses, one key benefit. Then these data ingestion and analytics pipelines in real time lower operational risk, and you are able to spot anomalies before the damage occurs. Then there are fewer false negatives. You detect subtle high risk patterns, and you can comply with the regulations much better by real time monitoring mandates, right? On anti-money laundering, SOX requirements, etc., etc. So those are some of the business impacts. Now, what do we do next? So in the next one, we will look at the second part of real-time monitoring and alert, which is using the AI-based anomaly system that triggers alerts when thresholds are breached. So how do we do that? We will take a look at in the next lecture. So thank you so much for watching this first lecture on real-time monitoring and alerts in this course, AI for Risk Management and Compliance Excellence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need to.